Try this one. The inverse sine of -1/2. The inverse sine of -1/2. No calculator. Okay? Your quiz next week will be no calculator. There are times when we need to use a calculator if it's not a special ratio, but on the quiz they will be. So do this without a calculator. Draw a picture, that's the key. Now let's talk this through as our first example. First of all, how should you read this? Well, it says the inverse sine of -1/2, but are you listening?
Yes.
When you see inverse sine, what you should be thinking in your mind is the angle whose sine ratio is, in this case, -1/2. That forces you to think about two things. What's the input, what's the output? The angle whose sine ratio is -1/2 means -1/2 is the ratio, and your answer is going to be an angle, so it should either be in degrees or radians when you're said and done here. So, if the sine ratio is -1/2, let's go back to section 4.4. In what quadrant is the sine ratio negative? Sine ratio is negative in and no.
2.
No. 3 and 4. The sine ratio is y over r, right? The sine ratio is y over r, and that's only negative when you go down, because that's where y is negative, right? So that would either put you in quadrant 3 or 4. But I told you that if you see the inverse written from the get-go in the problem, we assume it's a function. So we can't have two outputs. We can't use 3 and 4. We've got to pick one of them. This is where we go to those restrictions that Emma so kindly erased for us. Okay? Where is inverse sine restricted? It's either 1 or 4. 1 is not where sine is negative, so you should be drawing this picture in quadrant 4. Go ahead. Label the sides. You know the opposite, and the hypotenuse is the y over the r. So the y must be -1, the r is 2. Can you use Pythagorean theorem to figure out the missing side? Yes, you can. What would that missing side be? Square root of 3. Hey, that's a special triangle. What is that reference angle?
Negative 30.
I'm talking for this. Yes. You must memorize the restrictions because they're a matter of convention. So you must memorize them just like you memorize the order of operation.
Are we funny?
We need to find the
Memorize these
actual.
restrictions. These are the proceeding order of operation.
Versus sine positive ratio gives you sine.
Now, up front we have two answers of 330 degrees. How many agree? How many disagree? Why do we disagree?
Negative pi over 2 to positive pi over 2.
Because it's not between negative pi over 2 and pi over 2 radians or negative 90 degrees. Exactly right. Exactly right. That is not within the acceptable range. And I know this is your first example, but you have to memorize those restrictions. Inverse sine, if it's written from the beginning, means it's a function. Means those restrictions are in place. And that's said from negative 90 to 90 degrees. So 330 is coterminal with it, but what angle is it? No, 30 degrees is in quadrant 1.
What? -30.
Negative 30 degrees. That's the only acceptable answer in degrees. There's also one acceptable answer in radians. What is it? Negative pi over 6. Those are the only two answers that would get you full credit here. Negative 30 degrees or negative pi over 6 radians. Any questions? Questions, yeah. You can't draw in a quadrant 3 because of the restrictions. You have to go by the restrictions. Negative 90 to 90 degrees. You can't go outside of that range because it has to be a function. And we've agreed on that region. Okay? What are we up to time-wise?
4 minutes.
Good, keep rolling. Here we go, next example. Next example. The inverse, let's do this. The arc cosine.
What?
ARC COS.
Same thing.
ARC COS. The arc cosine of 1. Now, what is arc cosine? What is arc cosine?
Same thing as inverse.
Exact same thing as inverse cosine. Why do we have two ways of doing this? I don't know, but we do. It's just like we have two ways of showing inverses. It's like we have two ways of showing function composition, right? F of g of x is the same as f of g of x. So arc cosine is the same as inverse cosine. It means the exact same thing. Arc tangent means inverse tangent. Arc sine means inverse sine. So don't get hung up on that. You'll see both of them. It means the exact same thing. But what should you be thinking when you see arc cosine? You should be thinking the angle whose cosine ratio is, in this case, 1. Where does that happen? Draw a picture. Make sure it's within the acceptable range for arc cosine, inverse cosine. What were the restrictions on inverse cosine? They're different from inverse sine. Remember what they are? Did you memorize it already? 0 to pi inclusive. So where does the cosine ratio equal 1, given that it has to either be in that region between quadrant 1 and quadrant 2? Positive y-axis. The positive y-axis. And what is the angle on the positive y-axis? 90 degrees is acceptable. What else is acceptable? Pi over 2 radians is acceptable. That's it. Those are the only two acceptable answers. So let's take a look. If I can jump in here for a second. So the cosine ratio is 1. That's the ratio x over r. Draw it. How can a leg be equal to the hypotenuse? It can't. So where are we?
You're on the
It's
x-axis.
quadrantal. Well, we could be on the x-axis, maybe.
Yeah.
But
why
if-
not then?
Oh, did I say cosine was 1? I was thinking sine. Yeah, this is wrong. Sorry.
Aw.
So, right? So this is the ordered pair 1, 0, right? This is the ordered pair 1, 0. And
Oh my gosh.
what is this? X is 1, y is 0, r is 1. This all goes back to sections 4.2 to 4.4, right? All goes back to sections 4.2 to 4.4. So what do we have here? We're looking for the cosine ratio to equal 1. We want to know what that angle is. Well, cosine equals 1 right here, 1 over 1. That angle is 0. So it's either 0 radians or 0 degrees. Those are the only two acceptable answers. If this had said the inverse sine of 1, then we would have been up here. That would have been the 90 degrees of pi over 2 radians. So be careful. But those quadrantal angles are still important. You still need to know how to work with those. Okay? Let's try one more. Do we have time for one more? Bill?
Yeah.
All right, here we go. The arc tangent.
What's good?
The arc tangent of the square root of 3. That's it. No calculator. The inverse tangent of root 3, that means the angle whose tangent ratio is root 3 over 1. Did you draw a picture of it?
Yes.
What quadrant did you put it in? Tangent is positive in quadrants 1 and 3. But arc tangent is only defined in quadrants 1 and 4. So you should only be using quadrant 1. You have to memorize those restrictions for the inverse trig function. What? It's from negative pi over 2 to pi over 2 radians exclusive. So we're in quadrant 1. Draw the picture, label the sides. Root 3 is the y, 1 is the x, 2 would be the r, the hypotenuse. That's a special triangle with a 60-degree reference angle. But in quadrant 1, the reference angle and the actual angle are the same thing. So 60 degrees is acceptable, or pi over 3 radians would be acceptable. Questions? Want to go with that? Yeah, good. Bill?
How would it be different if we just did tangent? How would it be different if we just did tangent?
Tangent of what?
Tangent of root 3.
You're trying to break my heart, aren't you?
Whoa, whoa.
I
You're going to tell me
don't
you're going to take
know.
the tangent of a ratio.
Oh, you're right. Sorry.
Thank you.
It was an accident. I wasn't thinking.
That's why I say, and you know what? You're not the only one. A lot of people don't think when they're doing trig. Pay attention to what the input and the output are, right? Tangent of root 3 doesn't make any sense unless you mean root 3 radians, right?
I didn't.
Which you did?
No.
Oh, you didn't, yeah. So yeah, if it's a ratio, it's inverse. It's the input for an inverse trig function. Good. Okay. Kill the video.
You getting that?
See.